Hello, ladies, gentlemen, and non-binary. Happy fall, y'all. I'm Amelia Thompson, and welcome to the first day of autumn. It's a crisp, clear morning here in Watertown, South Dakota. And joining me and returning to the studio, Stefan Bachel, Field Application Engineer Extraordinaire with Wurth Elektronik in Germany. Hello.
Hello.
Today, we are going to be discussing the awesome power of USB Type-C with our webinar, USB 3.1, More Than a Connector, a Solution. If you have any questions during today's webinar, make sure you ask them in the questions box and our presenter will answer them at the end. If your question doesn't get answered, maybe you think of it a little bit later, or you want to go into detail with your application, make sure you just reply to our follow-up email at here4you@we-online.com. Because you registered for today's webinar, great news, you're going to automatically receive the video on-demand recording and a PDF of the slides when they become available within the next 24 to 48 hours. Simply look for the link in your email. Next week, don't miss our new LED webinar. It's a very hot topic at the moment. It's UV LEDs for disinfection. I wonder why it's going to be so popular. Register online at www.we-online.com/webinars. And of course, huge thank you to our exclusive sponsor of all Wurth Elektronik webinars, our neighbors over in Minnesota, Digikey Electronics. I'm now going to hand it over to Stefan as he proudly presents USB 3.1, More Than a Connector, a Solution.
So thank you very much, Amelia. So I have to share my screen now. So I think it should work. Good morning, America. Good afternoon, Europe. Hello to everybody all over this nice planet. I'm happy to have you here today. So thank you for registering and thank you for joining the webinar. So today, my name is Stefan, and I work for the Würth Elektronik company now since 10 years. I'm field application engineer located in the south of Germany. And I'm responsible for the customers here, but also do international integration trainings for our technical academy and also some webinars and seminars for our customers. So let's go to the topic today. Today we will not talk about USA. Today we will talk about USB. So you might have seen another presentation or webinar regarding the USB-C topic already with Wurth Electronics. This was done by my colleague Fabian Altenbrunn, but this one is more related to how you can solder the product, how you can bring it to the PCB and so on. And today I want to give you a little bit an overview of the different USB types on the market, different USB standards on the market, and I will show you how you can establish a good power delivery application with USB-C. And we will get started with the topic now. So, a small agenda for a small presentation. Our presentation today will take around 30 to 40 minutes. And after that, I'm here for your questions, for sure. We can go over your questions and talk a little bit together. So first of all, we will see some information regarding the general information of USB. Then we will hand over to a little bit of the connector features, cable features, and the power delivery. How does this work together? And at the end, I will tell you a little bit about the USB-C shieldings and about the reliability tests we've done with our connectors. Another thing, during the presentation now, I will switch off my camera so you can concentrate on the topic and not on my face. So I think that's a little bit better. So I will switch off it now and turn it on again when the Q&A session is starting. Okay, let's start with the first slide. USB, what does this mean? USB is established, it is a universal serial bus organization. It was established a long time ago, already in 1994, by Intel, IBM, and other players, some major electronic companies. They define the USB standards, they define how to design the connectors, they define also the protocols and how the connectors have to be tested. So the standards of USB are free to use, and manufacturing of the products are also free to use. But if you want to use a logo of USB, it must be paid. So, and they can be used only if the products you use are certified by USB organization. So what does this mean? This means TID listed. What's the meaning of TID? It's meaning test identification. And a TID list is a list of products that are fully designed and tested according to the USB standards and recognized by USB-IF. USB-IF, you can see it on the screen. It's the Universal Serial Bus Implementers Forum, and they are integrated in the USB organization. And all of our Type C connectors are TID listed. That means on one hand, you have a safe connector in your application, and on the other hand, you can do a USB conform application with a logo on it because you use a test ID certified product. So take care, if you want to do a USB application, please use only TID listed connectors. All our connectors are listed by USB. On the screen, you can see also some different logos from USB. That's only because of the different standards which were established in the past, but this I will show you on the next slide. A little bit of the USB history. Regarding the connectors, it started all in 1996, 2 years after the founding of USB. And there it started with a USB 1 interface. This was a really slow interface with a speed of 1.5 megabit per second. 2 years later, we got a little bit more speed, 12 megabit per second. The second generation, it was USB 1.1. And we had only 2 connectors, the USB A type and the USB B type, with just 4 pins inside, and that's all. Then a big development came in the early 2000s. Then USB 2.0 was established. With a USB 2.0, we already have a speed of 480 megabit per second. And there was another thing which was great, the recognizing of the device. That means if you use USB 1.0 and you want to plug in, for example, a mouse on your computer, then you have to install also a driver and say the computer that you have a mouse here. With a USB 2.0, this was not necessary anymore. The mouse was recognized by the protocol and the driver was installed automatically. This was a big step. So the USB interface became more and more popular. So a few years later, around 2003, all the small USB connectors came on the market, the mini USB connector, and a little bit later also the micro USB connector. And something else was implemented, the on-the-go supplement. What does this mean? This means if you have a small connector like a mini or a micro USB, it can be plugged into a slave or it can be plugged into a master device. But the system has to recognize which device you have. So you have 1 pin more, those connectors have 5 pins, and this is for the on-the-go supplementation. And it tells the protocol which system you have plugged in, if it is a master or it is a slave. One thing regarding the mini USB, I want to tell you, if you want to do a new design with USB, please do not use a mini USB. Because the mini USB is dying soon, it's obsolete soon, because the micro USB has exactly the same features, is a little bit better, it has more mating cycles than the mini USB, and it's a little bit smaller. And the electrical and the mechanical performance is the same. So that means the mini USB will not be available for a long time. If you want to set on the future, use a USB-C or at least a USB micro B connector. After that, 2008, 2009, there was a new standard established. It was USB 3.0, and it has a much higher speed. It has a speed of 5 gigabit per second, and this was possible with 4 additional contacts or 4 additional cables, which are installed between sink and source, and that means you can send the signals at the same time in both directions, and that increases the speed up to 5 gigabit per second. This was really a big step. And also a second big step came in at this time, the possibility to charge some batteries over USB. And this became more and more popular because of our mobile phones. They are all meanwhile all powered by USB. And the battery charging with USB 3.0 was very good. We have already 5 volts and 1.5 amps, and you can charge a mobile phone fast or a small device. And as you can see, the Micro B is a little bit thicker than the Micro B 2.0. That's because of the 4 additional contacts inside. They are here on the left side, but this product is still compatible to the 2.0 standard on this side of the connector. That means you can plug in this Micro B 2.0 connector also in the receptacle on this side of the Micro B 3.0 connector. And in 2013, the next step was released, the USB 3.1. And together with the USB 3.1, also a power delivery function was established, which is able, meanwhile, to deliver 20 volts and 5 amps to the system. This is really, really a lot. So the USB 3.1 standard becomes more and more popular, and there was also a new connector established, and this is our Type-C connector, which we talk today and where we will see a lot of slides later. Coming to the next slide, we talk a little bit about the Type-C basics. Here on the picture you can see a notebook of our days, and there you can see a lot of different interfaces. On the left side we have a power jack just to bring the power into the notebook. Then you see an Ethernet modular jack just to get a connection to Internet or Ethernet. And for the display you have the possibility with an analog D-sub connector or with a digital HDMI or DisplayPort connector. And you have, of course, a USB-A on your notebook, and you have an audio jack where you can plug in some audio devices. And all those interfaces can be replaced by only one, by the Type-C connector, as you can see right in the picture. And this is really great, and this is why the title of the presentation is the USB-C is not only a connector, the USB-C leads to a solution. This USB-C connector now is able to give you, with a 3.1 standard as example, 10 gigabit per second speed, and it's ready for alternative modes like Thunderbolt 3 or HDMI, DisplayPort, audio, many, many more. And it can handle a power delivery function up to 100 watts. That means 20 volts and 5 amps. Of course, you have to make sure that your device is ready for 20 volts, and then you can deliver the 100 watts. It is a reversible connector. It has a lot of mating cycles. 10,000 mating cycles are possible. And it is TID listed. It is a safe connector for your application. So Type-C is not a new protocol. This is a new cable and connector definition where you can run different existing protocols. For example, you can run USB 2.0, 3.0, 3.1, 3.2, 4.0, Thunderbolt, HDMI, power, audio, more and more things over this connector. Until now, when you see a cable or a connector, you know the protocol you have inside. For example, if you see an HDMI connector, you know exactly this is an HDMI connection. But that's not the case anymore with the USB-C. A cable and a connector Type-C cannot say what's inside. That's a strength, but on the other hand, also a weakness for the power. Which cable is allowed for what kind of power? Sink and source are able to deliver or receive what kind of power? You have to take care of what kind of voltage and current you want to put from your source through the cable to the sink. For example, not all the cables on the market are designed for 5 amps. So it's not possible to put 5 amps everywhere without any verifications. And therefore, we have the power delivery function. If you do not respect this, if you take the wrong cable for power delivery and you do not have a chip which recognizes the cable, then you can run into trouble and the cable or the sink can get too hot or even burn. And this we should avoid, and how this works I will show you later in a few slides. But first of all, I have an overview of all the existing USB versions at the moment. There you can see it started all with USB 2.0, and meanwhile we are at USB 4.0, and we have already a speed of 40 gigabit per second, and this is really, really fast. And the power delivery of 20 volts and 5 amps are possible in our days with this small connector. It gives you an overview of the principal characteristics of a different USB. Important here is the limit of the power delivery that is mandatory. So from 3 amps on, cables must be E-marked to be able to deliver 3 or 4 or even 5 amps. Standard USB cables can go up to 1.5 amp. For 3 amp and 5 amp, they must answer to the power delivery system if they are able to give authorization through source to allow the current. 20 volts request also power delivery system because not every device is ready for 20 volt powering. So Type C could be USB 2.0, 3.0, 3.1, 4.0. That is not the case for the other types of USB connectors. Type C is the only connector that is able to have all types of USB protocols. So after this table, we will have a closer look on the pinning of the connector regarding the standard USB 3.1. So here you can see a receptacle and the plug on the screen, and the pinnings are a little bit different. We have 24 pins in the receptacle and only 22 in the plugs. So that's the reason therefore is, so for the first standard 3.1, the first generation, you do not need the two additional contacts in the plug. Because the detection function, if you plug it this way or that way, was detected by this system. So if it was connected to the top of the receptacle, the system knows how to send the signals. And if it's connected to the bottom of the receptacle, the system also knows how to send the signals. But in 3.2 and 4.0, this is not necessary anymore because this is handled by the configuration channel on our connector and not over the D+ and the D- channel. And that means if you want to run a Thunderbolt 3 or if you want to run a USB 4 application, you have to use a plug with 24 pins inside. It's also available. So Würth Elektronik offers two different plugs, one with 22 pins and also the other one with 24 pins for the latest standard, for the new standard 4.0 or Thunderbolt 3 with a 40 gigabit per second. Therefore, we need the 2 pins for additional signal transporting. On the left side, you can see a little table, and there is also something highlighted, so the so-called mating sequence. There is a 1 and a 2, and that means that different contacts are contacted before the other ones. Why? Now this has a reason. So shielding and ground are connected, and the V-bus pins are connected first, and then the signal pins are connected. And the reason therefore is when you unplug it, then the signal pins get disconnected first. When they get disconnected, the system knows they have to switch off the V-bus power not to get any sparks while disconnecting the whole system. That's very important, as we will see later, because if you disconnect a V-bus and you have 5 volt and a 20 volt and 5 amp application, it will destroy your connector very, very fast. So what we see else is that the pinning for the Type C 2.0 is very easy. I will show it here in this slide. There you only have to use the D+ and the D- and the V-bus, of course, and the ground, as we had it the 4 pins in the USB 2.0 connector A and B before. And on the plug side, on the receptacle side, the same thing. You only have to use those pins for USB 2.0, for example. But we have another special features on our USB-C connector. Regarding this, I want to first show you the SBU, the sideband use pins. They manage the alternate modes and the audio mode. So if you want to run Thunderbolt 3 or DisplayPort 1.3 or HDMI, PCIe Express or audio, then you have to use the sideband use pins, and they can configure those systems. We have another special on our connector. It's the so-called configuration and VCon channel. The configuration channel detects all connections, if it is plugged this way or the other way around, as I told you before. But it also detects the cable orientation with the plug VCon, and it manages source to sink connection. It asks the sink for which voltage it's possible to deliver, for example. And then it manages also the power delivery function. and it manages alternate modes and accessories like the cable. And therefore we need the VCon pin. The CC in front of the VCon becomes to the VCon pin, and it's a powered circuit in the plug for so-called E-marked cables and devices, and it brings you a power up to 1.25 amps. And now when you have the correct cable, which has an E-mark inside, this is only a small resistor, then the system knows, okay, this cable is ready to deliver 3 or 5 amps, and the power configuration can start and the power delivery system can run. So the conclusion of this, the migration to the Type C is not so simple. It's not a simple mechanical connector swap. The electrical implementation is more complex and has to be respected in a good way. So it must comply with the USB standard, of course. It must advertise properly everything, even with a dead battery. It must discharge the V-bus at disconnection. This is very important, not to get any sparks at 5 amps. It must identify the connection type object, if it is a source, a sink, or an accessory, a cable, for example. And it must ensure the self-protection against defective connected objects. So when you regard the USB standard, then the standard requests source auto protection and a sink auto protection. The standard does not request that source protect the sink and reverse. So now we come to the power delivery system. How can you establish a proper power delivery application? So the easiest way to do that is a so-called cold socket. Here you can see a cold socket application. Yeah, that means that the V-bus is not under voltage before the power delivery configuration channel authorization. So no hot swap when connected and no sink or source damage to destroy by too high voltages or currents. And this is very important because, as we see, V-bus and ground are connected first before the data pins. So how does this work? So the first situation is the configuration channels asks the sink, so which voltage do you need for the power delivery? And for example, the sink says to the configuration channel, I'm able to handle 20 volts. Then the IC says, okay, the configuration channel can enable the power for the power delivery application and gives power on the V-bus. But the bad thing is the system does not know if your cable is able to send those 3 amps or 5 amps. Otherwise, the cable can get too hot. So this is a little risky application. The better way to design it is to have another IC, an IC with an integrated V-bus switch. How does this work? It works in the same way. So first the IC is asking the sink which voltage is good for you. And we take the same example. The sink says, okay, 20 volts is fine for me. I can handle it. Then the IC is asking the cable, hello cable, are you able to transfer 5 amps? And then the cable gives a response over the E-marker and says, yes, I'm able to transport the 5 amps. And then the V-bus switch is enabled and switches on the power for the whole system. This is a really safe system, and there are IC chips on the market which can handle this. For example, from ST Micro, it's also a partner of us. The USB Type-C controllers from them, they embed the V-bus monitoring for active protection, also high voltage immunity on CC and on the power pins, and a correct advertisement even in dead battery situation. Small picture for you. For example, the ST USB 4500. Here you can see a small reference design, and you can see there's also a Wurth Elektronik connector on it because it's TID listed. So this is a really a good IC which you can use if you want to establish a good power delivery application. But of course, there are also other brands on the market. But what happens if we have a hot swap situation and we unplug the whole system with 20 volts and 5 amps? We just made a test about this. Here you can see some pictures, and this test shows what happens if power delivery suddenly becomes unplugged. Cold socket means that it's not possible to have voltage when plugging, so no spark and voltage discharge. But in case of unplugging under load, a hot swap situation, the data pins are disconnected first, and then they stop the power limiting spark and the hot swap effect. That's how it works in the real situation. But we did the same durability test, but under load. So we plugged and unplugged under the maximum current of 5 amps. That means 1.25 amps on each VCC and ground pin. Type-C connectors as well as all USB connectors are not suitable for plugging or unplugging under load. Cutting power creates a spark that has a high energy level regarding current and duration. So you can see after the second cycle, we can see first burning points on our connector. And it gets worse after 5 cycles, and it gets even worse after 13 cycles. There I've got some more pictures for you, and you can see after the 13 cycles, the connector is really destroyed. The plastic material is destroyed, but also the contacts are destroyed. The plating is gone. So the resistance is rising and so on and so on. You should not do that. The conclusion is a hot swap is not a good idea at 5 amps. Let's have a closer look to the cable. Here on this picture, you see a really good cable, which is able to handle a power delivery up to 5 amps and also able to handle all the USB new standards. This cable has a double shielding, copper tin braid and aluminum foil. It's called an SFTP cable. The TX and RX, 2 for each side, 1, 2, 3 and 4 here, the twisted pairs, they are shielded with an aluminum foil. This is requested also by the USB standard. And it has also a drain that will ease the connection of the shielding on both sides of the cable. 1 cable for each feature, CC, VCC, VCon and ground. 2 cables, SPU1, SPU2, VCC and ground are bigger designed for 1.25 amps than the signal cables. They are only designed for 0.25 amps. So there you have to take care. If you only have signal cables with 0.25 amps, this cable is not suitable for power delivery. The plus and minus, they are not shielded. It's not necessary because the frequency is lower here and the data speed is also lower, and it's not necessary. However, the pair is twisted. All drains and ground are connected in the plug PCB on cable on both sides. And this is also a very important thing because the external and the internal shielding have not to be connected on the PCB. They are already connected when you use a really good cable for your application. They are internal twisted pair shielding connected to the external shielding. Ground is not connected to the shielding in the cable. So now we come to the next point regarding the tests we did with our USB connectors. So all tests we did are defined in the standard in the USB serial bus Type-C connectors and cable assemblies compliance document. Revision 2.0, it was established in April 29th in 2020. And for example, the first standard we use for the contact resistance test is the EIA 364-223. It's a low-level contact resistance measurement. Therefore, we use 20 millivolts at 100 milliamps, and the resistance is not allowed to go higher than 40 milliohms initial, and after all other environmental tests, it may not exceed the 50 milliohms. And for the connector insulation, we have the EIA 364-20, sorry. It says 100 mega ohm minimum between ejected contacts, mated or unmated, as you can see on the right picture. And it says it must have a dielectric withstand voltage of 100 volts during 1 minute. So this is what we tested, and I've got a very small video for you. And in this test, we did not do it with 100 volts. We did it with 1,500 volts just to see what happens when the tension is too high. So please have a look on the connector now. Okay, you saw the small spark between our contacts in the connector. And when we break up the connector, we will see things like that. There's a carbon path after breakdown between the 2 pins we had with those high voltage. But this is not so dangerous because we have a material called LCP inside, and LCP is a plastic material which cannot burn so easily. So the connector will not burn, it will just get destroyed by this. And remember, it took 1,500 volts to destroy this connector. That means data sheet says 100 volts, and real breakdown is at 1,000 volts. The next test we did is the current rating test. And when you remember our webinar regarding derating, there's a rule by the UL organization which says the delta T should not be higher than 30 Kelvin at the connector at full current at all pins. And to respect the UL standard, we did a test and we put on the 5 amps on our connector. So all V-bus and ground pairs are powered with 1.25 amps. We have 4 of them, so we have the 5 amps, and we send it from the source to the sink and back to the source. And then we made some pictures with the thermal camera, and then we see that the connector delta T is not very high. So if we look at if we put 3 amps on the whole system, we get a delta T from the connector, it's the red line, around 10, 11 Kelvin. End of the cable, the gray line, around 10, and the brown line is the PCB, only around 5 Kelvin. Yeah. And the next test we made with 5 amps and also with a 5 amp cable and with a 3 amp cable. There you can see a little bit of difference. So the red cable is suitable for 3 amp and the gray cable is suitable for 5 amps, but at the end they are all the same cables. They have the same AWG inside, but we did not know this before because only one of them, the 5 amp cable, has the E marker inside and can say the system, I'm suitable for 5 amps and you can use it with the 5 amps. And when we look at the delta T of our connector, we must respect the 30 Kelvin. We do not reach it. We stay at 20 to 25 Kelvin. So this is really not a problem with this small connector to handle 5 amps and 20 volts. That means really 100 watts are possible over the small USB-C connector if it is a good quality. Next test we did mechanical tests. The plug and unplug resistance. It has an insertion force of 5 to 20 Newton, extraction force initial 8 to 20 Newton, and after 10,000 mating cycles, which is suitable for, it should stay between 6 and 20 Newtons. To see what's meant there, I've got a little example for you. 1 liter of milk is 1 kilogram. It says 10 Newton around, so it should withstand those 10 Newton, those bag of milk. And the durability, it says with low load, 10,000 cycles must be possible. And the resistance, the initial resistance has to be lower than 40 milliohms and the final resistance has to be lower than 50 milliohms. So we did these tests and we can see we are far away from the standard here. So after 10,000 mating cycles, nothing happens. After 30,000 mating cycles, then the connector starts to get destroyed. What is happening here? Then the resistance of the V-bus pins and go a little bit up, get a little bit higher. Why? Because you scratch off the plating, and the first plating we have on our connector is a gold palladium plating. It has a very low resistance, and when we scratch it away, we reach nickel, and nickel has a higher resistance, and that's the reason why the curve goes up here after 30,000 mating cycles. And then it goes down again. That's a little bit strange, but if you know the reason behind, it's not strange anymore, because when we scratch more and more on our product, then we remove also the nickel plating, and under the nickel plating we have a pure copper, and the pure copper has a lower resistance than nickel, so the resistance goes down a little bit again. But it is not good to do it because then you have problems regarding oxidation. A few pictures. After 50,000 mating cycles with the USB-C, there you can see there's a lot of plastic material on our contacts and the connector is really hard destroyed. And when we look at the plating on the right side of the picture, you can see really that we scratch down to the pure copper, and the pure copper resistance is that what you saw the table before. We come to the next environmental test. It's the EIA 364-17 regarding vibrations, temperature life, and so on. For temperature life, it must withstand 105 degrees during 72 hours. And also we test the resistance before and after. The vibrations, it has to withstand 10 to 55 Hertz at 5G during 15 minutes in 3 axes. And there have to be no electrical discontinuity, bigger than 1 microsecond. So And the resistance, the initial resistance has to stay under 14 milliohm again, and the final resistance under 50 milliohm. And this worked. Next test is the cycling temperature, humidity, and thermal shock. There we did it at 40 degree at 19, at the humidity 19 to 95% relative humidity for 96 hours, and also measuring the resistance before and after. And with the thermal shock, we put on minus 55 degree and plus 85 degree for 10 cycles, and also did a resistance measurement afterwards. And everything worked on a proper way. So you can see that you really have a provable connector for your devices here. So what do we have to respect when we want to change our connector on the application? So it's not so easy to change a USB-C connector on the application. It is easy to plug a USB-C connector from another manufacturer into a receptacle of another manufacturer, because this is all mandatory and this is all designed by USB, and all the manufacturers has to respect this design, as you can see on the left picture. So the face of the connectors, the interface have to be the same everywhere. But if you look at the PCB side, the PCB layout is just a recommendation. It's just for information. So there you could find a lot of different PCB layouts regarding different manufacturers, and it's not so easy just to replace a USB-C connector from one manufacturer to another manufacturer, because everybody wants to optimize this to get a proper solder connection, to get the proper routing options, and so on. So it's not the same with every manufacturer of USB connectors. On the other hand, the pin length, the pin depth, this is all defined, and also the face, but not the side on the PCB. There you have to take care a little bit. So let's have a look on the shielding of the USB-C connector, because the shielding is important when you want to use it for the high speeds, like 40 gigabit per second. There you have to respect that you have a really, really good shielding connection everywhere in the Type-C connection. When we look at the external shielding connection, it's done in a good way. So we have a completely closed housing for the external shielding, and also the plug has a completely closed housing for the external shielding, and it's connected on many, many points inside the receptacle and the plug. There you can see the points where the external shielding is contacted between the plug and the receptacle. The internal shielding is also available. So this internal shielding is on the plastic part here in the receptacle, as you can see with the blue rings on the right and on the left side. And also in the plug, it's located here with those springs. And those springs, they contact those materials here in the receptacle. And then we have an internal shield connection between receptacle and plug, as you can see here in the picture. And this is also important when you want to use the high-speed functions of the connector. And when we look at the receptacle itself, there is a shielding connection standard rule. All shieldings should be connected, especially for high frequencies. But the mid-plate pins, we also have them on our connector. They could not be connected without big consequences. So, but the question is, do you have to connect the inner shielding to the outer shielding? So as we saw with the cable before, when you use a good cable, the shielding is already connected inside the cable. And it's not necessary to do this on the PCB because it's very complicated. Why is this complicated? You have to use another layer, another ground layer to route this, and this ground layer has to be connected to the other ground layer on your PCB with via fences and so on. And this is a little bit more design effort as you have when you just have only the connector and for example 4 PCB layers inside. So you have to think about it if it's necessary or not to connect this to the PCB. So the internal shield connections between the receptacle and the plug itself, you can see here in the picture, it's also released with those small springs inside of the plug. And here you have a side view of this really small but complicated mechanic connector, and you can see how all the shielding works together and how they are connected together. And this establishes really to use it for high-speed applications up to 40 gigabit per second. So now we come to the last slide of our presentation. It says it's something about the PCB connections. The 4 ground pins are connected together always. The V-bus is the same. And the shielding are connected before plug and after receptacle. It's good to have the shielding connections already in the cable. Then you do not have to do it on the PCB. So I hope you could enjoy this presentation a little bit. And now I am here for you and I wait for your questions. Thank you very much for listening to my presentation. And I will switch on my webcam again. So my question is, Amelia, are there any questions coming in from the audience?
Oh, you bet there are. We do have a few coming in, and as we mentioned before, if you do have very specific questions or you think of them later, simply reply back to our email at hereforyou@we-online.com. Let's go ahead and take a look at our question. The first one, where can I find the information on how to implement another system like the Thunderbolt to the USB connector?
Okay. Thank you. This is really a good question. This is not so easy because there are a lot of different protocols possible with the USB-C connector. I think the best way is you ask the manufacturer of your IC. When you want to implement, for example, Thunderbolt 3, you have to buy a Thunderbolt IC. You could buy it from Intel. It was developed by Intel, for example. And the Intel can give you also information how to route this with a USB-C connector in a good way. So it's always the best idea to ask the IC manufacturer which IC you use. He can tell you how to route and how to establish the whole system with a Type-C connector.
All right, excellent. Thank you. Our next question here. These connectors, especially the hybrid types, they are hard to solder and to route. Do you have any additional information for PCB designs?
Yes, thank you for these questions. We have a design guide on our website. So if you just click on the USB products, the USB connectors on our website, you will find also a design guide with everything inside, how to solder the product properly to the PCB. I know this is a little bit tricky because of the hybrid connector. It has SMT pins and THR pins, and the THR pins have to be filled at least to 75% with the solder with solder balls and so on because of the IPC. But this is also everything is highlighted there in the design guide. You can download it from our website directly.
Our next question here, is it necessary to contact the inner shielding when they're using USB 2.0 and power delivery?
Sorry, I did not understand acoustically the last sentence. Can you repeat, please?
Yes. Is it necessary to contact the inner shielding when I use USB 2.0 plus power delivery?
Oh, in this case, I think it's not necessary to contact the inner shielding because the speed of the 2.0 is not so high that you need a contact between the inner shielding and the outer shielding. When you want to use USB 3.1 or higher, then it's necessary, but for 2.0, it's not necessary.
Okay. Our next question here. Can the USB-C through pin connector on your slide 31 be run on an SMD line without hand soldering?
It can be run on an SMD line without hand soldering, but it's a little bit tricky to do it. So if you want to know how to do it, you can download the application guide, and it's very good highlighted in this case. And if you have some questions to the application guide, you can also come back to me and write me an email, and I'll be there for you.
A few more questions have come in. Do you have a USB 3 connector that has latching style housing so the connection will not come apart unless you want it to with pulling it?
No, we do not have, sorry.
Our next question here. Can you please tell us about limited power source measurement in the USB and tell us about what are the limiting ICs or component for USB? And oh, one more part here. And do you ensure those IC or component safety?
Oh, I do not understand the question really. So I think it's about if it is safe to use the connector in every application regarding the power. So there you have to be sure that you have a TID listed product which you use in your application. Then you can be sure that it is tested by the USB organization regarding those standards, and it's suitable for the high power. It's important to use a TID listed product and not any product bought on a cheap market somewhere in Asia. That's in this case important.
Yes, absolutely. And because that one had so many parts to it, we can definitely respond back after the webinar. So no worries about that.
I will read the question again and think about it and write an email back.
Excellent. A couple more questions and then we will wrap up today's session. How can I recognize if I have a suitable cable for 100-watt power delivery?
So you cannot recognize it when you see the cable. You have really to ask when you buy the cable. So, and it's very important when you do a power delivery application and that you look for a good cable and you find it on the electronic market, and you have to deliver this cable together with your application to the end customer, because you cannot be sure which cable the end customer is using. And as we saw, not every cable is suitable for everything. So you have to deliver your cable together with your application to the end customer, and then you are sure that your power delivery application is running on a smooth way. But you cannot be sure when you see the cable that it's ready for 5 amps or not. So this E marker is very small and it's integrated in the plug, and you cannot see it on the cable. So you have to ask the manufacturer of the cable if this cable is suitable for power delivery, and you of course you have to ask for 3 amps or for 5 amps.
Excellent, thank you. 2 more questions coming in, and then we'll end today's webinar. Does the design guide that you discussed earlier protect against ESD?
Yes, there's also highlighted how you can protect your application against ESD, and we have some components for that in the passive components of the Würth Elektronik ISOs. There are also some specialists which can help you for your design regarding those features.
And our final question for today, are 10,000 mating cycles possible even with power delivery?
Yes, this is tested from our side and also tested from the USB side. You can put on the full power delivery, and also 10,000 mating cycles are possible. As you saw on the table before, even up to 20 or 30,000 you can do before something happens with the contacts.
Thank you very much, Stefan, for presenting today's webinar and for answering all of our questions.
You're welcome.
And thank you everyone for joining us for today's Wurth Elektronik webinar. Don't forget to register for next week's presentation. It is a very popular one. It's UV LEDs for disinfection, and one lucky attendee is going to win a phone disinfector and charger all in one from Wurth Elektronik. You can register online at www.we-online.com/webinars. You can also hear a lot of our webinars, our application notes, our blogs on an audio format with our new Wurth Elektronik What's Up radio podcast, available on Spotify, Google Podcasts, iTunes, and all major podcasting networks. So I hope to see you next week. Until then, I'm Amelia Thompson. I hope you have a great day.
Thank you very much. Bye-bye.